Okay, so we're going to be using Suvat, but for these ones, rather than going horizontally, we're starting to do vertical motion. So this means generally something's thrown up in the air and it also then comes down. Now with this, we need to make either up or down positive. I normally make up positive. There are some occasions when I don't, but normally I do, and I always put it in the corner as well of which way I'm going to do it. You'll see why that's important to start off with. So we're told that a ball is being projected, so that just means it's being thrown up in the air. When it's thrown, it's got a speed of 21. Now with this, we've got to remember that the acceleration is going to be the gravity. Okay, so for part A, we want to find out the greatest height. So Suvat. Okay, now we're trying to find the height, so we're trying to find the S. So I'm going to leave it as S. U is the speed that it started at, which is 21. Now, because 21, the speed that's going upwards, that's the one I'm making positive. Gravity's acceleration. Now, because gravity is down, pulling the actual object down to the ground, the acceleration is going to be negative. Okay, because if you think of an object, I'll do it over here. So let's say that there's someone with a ball. Okay, they throw it from the ground upwards. Okay, so the speed is going towards the sky, but due to gravity, gravity is a force that's pulling it down to the ground. Although the speed is positive, because I've said that it's positive here, the gravity is actually, or the acceleration is pulling it down. Okay, so that's why it's negative. Now, when something reaches the highest point, that means that there is no more speed going upwards, which means that the speed that it ends up with must be 0. Okay, so I'm just going to quickly get my little formula. So these are the ones that we've got to know. Okay, so the one that uses all of those is going to be number 4. So v squared equals u squared plus 2as. Okay, and then we just sub the numbers in. So 0 squared, 21 squared plus 2 times minus 9.8 times by s, because that's what we're looking for. So 0, 441, I will check that. 21 squared, yeah. And then I'm going to add the 19.6s to both sides. And then divide by 19.6. So the distance is going to be divided by 19.6, which is 22.5 meters. Okay, so that's the answer to part A. Part B. So it's asking for the time that the ball is in the air. Okay, that's what essentially what it's trying to say. So again, we're going to use Suvat. So we're looking for the time, so that's going to be there. We know the speed again is 21. We know the acceleration is minus 9.8. And we know that if it's going up and then back down, because it must start at the same point, we know that the s, or the displacement, must be 0. Okay, so looking at the formulas again, let's put it on here. So we've got s, u, a and t, so we're going to be using number 2. Okay, and then again we just sub it in, so 0, 21t plus a half times minus 9.8 t squared. Simplify it. So that's going to be minus 4.9 t squared. We can factorise it because they've both got a t in common. Okay, so we get 2 answers. We've got this one here. So t is 0, so that's obviously when it was first thrown in the air. And for this one, it's going to be 21 divided by 4.9. Okay, which gives me 30 over 7, or 4.3 seconds. So time in flight must be 4.3 seconds.